Hi, everyone. My name is Lum. I am a data scientist with Hewlett Packard Enterprise's AI and data integrations team. I'll be speaking to you on HPE's experience using graph databases to deliver real-time user-to-user connections in a complex data environment. Before I get started, this is a disclaimer on any forward-looking statements in this presentation. Give you guys a few seconds. For those of you who have not heard of us, Hewlett Packard Enterprise is a global company spanning 165 countries with 30 million customer contacts and 1 million partners to facilitate sales. We specialize in hybrid cloud, edge computing, data-driven insights, and security solutions. One special thing about HPE is that we do not make direct sales to our customers. All of our sales are through our partners. Hence, the goal of this project is to help customers find the right individual partners with the right set of product solutions for their specific project that matches their timeframe. When a customer is gathering information on potential products and partners that fit their use case, they're looking at things like a partner's product experience, the partner's company's experience, the partner's own sales experience, the partner's geographic proximity, and they're evaluating that against their own use case and their own install base for compatibility. The customer typically only spends 30 seconds looking at all this before moving on. And thus, a goal of the project is to deliver the best customer experience within that 30-second constraint, which requires us to deliver a real-time, seamless experience. Before I get into the solution, this is why HPE went with a graph database. The data powering this project consists of many-to-many relationships. For example, in the snapshot of our entity resolution diagram on the right-hand side, we can see how a partner can hold many certificates, each of which links to one or many products which are involved in many orders, which are bought by many companies. A customer, on the other hand, could have looked at many pieces of content on HPE.com relating to many different products, some of which the partner that they're looking at may have sold in the past, some of which they themselves have already bought. Joining all of these tables together would be computationally expensive and would run against our requirement to deliver a real-time experience. Additionally, the traditional machine learning models that run off of relational databases have limitations that graph databases solve. For example, k-nearest neighbors can't resolve complex data structures due to the need to one-hot categorical variables. If you look at the entity relationship diagram on the right, you'll see that there are going to be a lot of categorical variables that have to be resolved, and some of which there isn't a finite set to pick from as well. Random forests could handle that complexity, but it needs the data to be sufficiently filled out to do so. And that's something that we really can't guarantee when using offline data. To help customers and partners connect, our solution is to deliver targeted recommendations to our customers. To participate, a customer must first accept HPE's privacy agreement and consent to the use of this technology. Once they do, HPE provides them with up to 5 recommendations in 3 categories. Each recommendation comes from a distinct billing group and comes with a set of similar users as well. Charles here is coming to HPE to upgrade his network infrastructure. His browsing history on HPE.com and other data that he's provided during sign-up would be fed into our graph, and he gets back a set of recommendations. And here are the categories. HPE resources. These are HPE employees who can help Charles with setting up or troubleshooting once he makes a purchase. Partners. Partners are at the core of the project. They are whom Charles will buy HPE products from once he decides. Charles will be provided with each partner's contact information and location so that Charles can reach out and get a quote. And then lastly, our coworkers. These are other customers, HPE customers from Charlie's own company, who is either a current or potential HPE customer, and whom Charles can reach out to get some insight on how they are planning to or are currently using HPE products. Once Charles has made his selection, he can reach out to them, and if they meet his needs, add them to a project that he then manages. If none of these meet Charles's need, by clicking on each individual icon, he's able to see those who are similar to that particular person, and he can reach out to those people instead. To generate the recommendations for Charles, we run an ensemble of graph data science algorithms from k-means, weighted node similarity, and PageRank. We do this alongside traditional methods such as market basket analysis that are ran on a relational database to build out related systems such as content and product recommendations. We also make internal similarity metrics for some of the node types like company or industry, and that helps power the final recommendation. We generate the recommendations on Neo4j during off hours so that they may be available when the customer logs in the following day. To pull the recommendations for any user takes less than a minute, and to pull recommendations for all of our users and cache on the browser takes around 40 minutes. And this is across millions of records, and to do so on a relational database would take a couple of days. And this is how we meet our real-time experience requirement. This project provides HP's customers like Charles with data-powered recommendations from the moment that they sign up. It provides them with a small list so that they can evaluate, leading to much timelier decisions. These recommendations also change as we know more about Charles, right? So for example, as his needs change and he goes onto our website and browses different products, we can see that, and we can give him a partner that better recommends or better suits that particular set of products that he's looking at. This is an ongoing project, and we are adding more functionality to it in the future. Some of the additions are an approved product recommendation using data gleaned from the customer's interactions with the partners and resources on the user graph. Another is the integration of the user graph data with the reference architecture designer we call Visboard, allowing a customer like Charles to design his own solution with his chosen partners, or to design a solution himself and see which partners are best fitted to help Charles realize that solution. That's all I have for today. If there's any further questions, I would be happy to take them.